Okay, this lesson is from Unit 11-12. We're still looking at connections between relationships. This covers some more of the material in Section 12A here. We're still looking at matching up stories and slopes. And what we want to be able to do by the end of this lesson is determine the rate of change, or the speed, from a distance time graph. And this question that we're going to do is very much the same as the question that they ask you to do in Unit 12, Section A, page 1. So if you're looking at that problem there, this example should help you. So let's take a look at the problem first. Chris runs each day as part of his daily exercise. This graph shows his distance from home as he runs his route. Okay? We want to calculate his rate of change, or his speed, for each segment of the graph. So we can find out during which section is he running the fastest and when is he running the slowest. So this is a distance time graph like the ones that we've been working with. And the key thing that we want to use here is that if we're calculating his speed is the distance that he travels divided by the time that it takes him to travel that distance. So this is the information we want to get off the graph. For each section, we want distance and time. The easiest thing to do is take these points at the end or the beginning of each of my sections, and we're going to label these just with letters. So this first one will be A, then B, then C, then D, and finally point E. And the information that I want for each of these points is, what are the coordinates of these points? So I want the ordered pair, time, and distance for each one of these points here. So A is the easiest one. What are the coordinates of point A here?
0, 0.
0, 0. What about for point B? What is my time and what is my distance here?
5 and 200.
5 and 200. And I better clean this up a little bit so it's a little easier to read. 5 and 200. Point C, what are my coordinates up there? Well, let's see, I'm at 10 minutes. And what's my distance? I go across, and it's halfway between 800 and 1,000, so that's going to be 900. D, if I look at the coordinates here, let's see, 10, 11, 12, 13 is my time. And my distance is still 900. And what about point E? Let's see, what's my time? 15, 16, 17. The time is 18. And what is my distance from home there?
0.
0. So that's suggesting that he's back at home. And we want the speed for each of these sections. So if we're looking at section A to B, we want to know his distance and the time. How far did he travel during this section, and how long did it take him? So what distance did he travel going from A to B here? Well, if he starts at 0 for distance and ends up at 200, how far did he travel? 200 meters. How long did it take him if we go from 0 to 5? So his speed is going to be distance divided by time, 200 divided by 5, and we punch this into our calculator, and we get 40 meters per minute. Let's go on to the next section then. From B to C, again, we want his distance and his time. Well, for BC, he starts at a distance of 200, ends up at a distance of 900. So how far did he travel during this time interval? How are we going to figure that out? Well, let's see. If he ends up at 900 and he started off at 200, we want the difference between them. So 900 minus 200. So he traveled 700 meters. And let's do the same thing for the time. If he starts at 5 minutes, and at C he ends up at 10 minutes, how many minutes has it taken him? Again, we can do the subtraction. 10 minus 5, so it's taken him 5 minutes. So what's his speed? Well, distance divided by time, 700 divided by 5 is going to be 140 meters per minute. Now, does that make sense? His speed is much bigger in the second section than in the first section. Does that make sense with what we see in the graph? How can we tell that his speed is bigger in that second section? How do we know he's traveling faster in this section here? What does the line look like? It's steeper. Steeper line means faster speed. Okay, the next one is the easiest one. From C to D, what's his speed? He's not moving at all. His speed is going to be 0 from C to D. So C to D, speed equals 0. How do we know that? Because it's a horizontal line. All right, the last section, D to E. Again, let's figure out how far has he traveled here and how long did it take him. So how long did he travel from D to E? What was his distance here? Where did he start? From D to E, how far did he travel here, Drake? What was his distance? At 900. Because he started at 900, he ends up back at 0. So his distance is 900. And how long did it take him? Well, let's look. From 13 to 18, so how many minutes is that? Drake? 5 minutes. Good. So his speed is going to be, again, distance divided by time. 900 divided by 5 is 180 meters per minute. So, which of these sections is he traveling the fastest? Where does he have the greatest speed?
Going down. Or going down.
And how have we labeled that section? How have we labeled that section? A, B, B, C, C, D, or D, E? D, E, yeah. D, E is the fastest. Now, here's the tricky one. Where is he traveling where is he running the slowest? Which section do we think he's running the slowest in? Which one has the smallest speed? That's where he has the smallest speed. Is he running in that section? He is standing still in that section. So if we're asked where he's running the slowest, he has to be moving, but he has to be moving slowly. So which section is that going to be then? Yeah, so AB is the slowest. Is the slowest. And we should just put in brackets, he is not running in section CD. And then we're done. We've calculated this rate of change, or the speed, for each section of the graph.